longer, I will get away from the speaker. I'm with Cloudflare. So I lead solutions engineering with Cloudflare in Canada. I've had a 30-plus year career. My background in security started, and so I've kind of grown up with the evolution of a lot of the topics that we'll talk about today. I spent my career in mostly in Canadian finance. So joining us from a bank today, I've been in your data center, and you have trusted me in the past. I work with public sector, been an advisor to federal, provincial, and municipal governments. About 20 years of my career, probably let's just say the largest networking equipment vendor you can think of, consulting engineer. Today we're going to talk about zero trust, but not from the perspective of Cloudflare's approach to the problem. We'll share a little bit of direction from a high level, but certainly not talking about products and services. We want to talk about the history, what got us to here, and what we're seeing change right now. This is not a, I'm sorry, is everyone hearing? I feel the sound going up and down. It's okay, but you can hear me? This is not a hype cycle phenomenon, zero trust. As with many technologies, they show up, they emerge, they rise, cycle happens, technology rises, matures, settles off, and sometimes falls off. But we'll go into the history of what brought us to zero trust, because it's not a technology itself, it's a mindset and a philosophy. So that's the first theme. And for several of you, this is probably a little background, but I think it's good for level setting and introducing some of the themes we'll talk about. Zero trust is a mindset shift. It's a culture shift. It's a different way of thinking about the problem of security. It has a few key attributes that you're probably familiar with. Assume risk. I would go further and say assume breach. If you assume breach in whatever environment you're in, you're probably correct. There's some element of breach that's probably already happened. So assume you're in a dangerous environment. Start with a default deny type of perspective instead of an implicit permit with specific blocks. Least privilege access. Give people the least amount of access that are required to the data, applications, and systems that they need. Context-based refers to this concept that situations change depending on other variables. A given user that has access to something maybe shouldn't have access when they're using a different type of device or from a different location, or when it involves different data. So applications are not the lowest level of granularity to get into the authorization of users. Lateral movement is the theme of my next slide and is really close to my heart growing up with networking. And mutual authentication refers to the fact that we're all very aware of what it means to authenticate a user, but less familiar with what it means to authenticate an application. Because you can spoof applications just as easily as you can fake being a user. And so mutual authentication on both sides is really critical in this world. This is where I came from. Quick history, you probably all know. The internet started arguably 1969, first message between UCLA and Stanford. Wasn't technically the internet at that point, wasn't using internet protocols. Vint Cerf and team invented TCP/IP in 1973. And other TCP/IP-based services emerged around 1978. And I would say arguably the internet was born. Oh, sure, thank you. I need that, yeah, good. That's better. The key thing from a security perspective is that the internet was fundamentally built with no security controls, completely open. If you had access to a packet sniffer, packet analyzer, passwords as people telnetted into critical infrastructure were sent in the clear. It was a trustful environment, right? And so what we have now is an environment where we've snowballed a whole bunch of security technologies, packed them on to compensate for the fact that the internet was built with a trustful mindset. This architecture we lovingly refer to these days as the castle and moat architecture. And this was a concept that obviously came with a bit of maturing in the model of a completely open internet. But the idea that if you were in the castle, you were trusted, and everyone outside the castle was dangerous, and put some security controls at the perimeter. So the drawbridge and the moat represented the perimeter defense of a firewall, intrusion detection, where VPN devices terminate connections, and users, if they can connect to those, for instance, VPN services and terminate at the perimeter, they then become a trusted user because they are now securely inside the network. That touches on my last point on the last slide around, second last point, preventing lateral movement. It's one of the biggest risks that exists today still, despite all the complexity that we build into private networks to detect and mitigate lateral movement within an otherwise trusted environment. There we go. So where does trust exist? This is kind of the classic space. If you go and look up what zero trust is and what this mindset represents, in some way, we still do. Zero trust is not a complete concept. I won't pretend that Cloudflare or anyone else in the world can sell you anything that solves this whole problem, because it is a vast and diverse problem, and different organizations will need to tackle this challenge in different ways. But from a high level, users, devices, the locations they connect from, the applications they access, and by proxy, the data that those applications access are things that can be trusted and have historically been trusted a lot. But there's a lot of new things that are getting added to this list recently. Actions. We've probably all heard of AAA, including authentication and authorization of users who are accessing applications and data. But authorization, as I mentioned earlier, doesn't stop at the application level. It proceeds down into what users are doing within applications. We might be familiar with the area of privileged access management, which has often been thought of as a separate, distinct domain reserved for critical infrastructure and super users who have access to particularly sensitive equipment, and that we need to do more than just authorize them for access. But we need to be able to confirm what they're doing once they're connected, perhaps audit what they're doing when they're connected, because the changes that they make might compromise compliance, have regulatory issues, might impact other technology domains in ways that are very difficult to troubleshoot, and so we need a record of what happened. So this is the more fine-grained authorization that we see in the area of privileged access management, and these worlds are all becoming one right now. If you view these as distinct domains, the idea of privileged access management is very heavily bleeding into the world of zero trust authorization of everyday users to monitor, analyze, audit, ensure compliance in the actions that employees, partners, contractors, customers, what they're doing with their data through the applications they're authorized to access. Supply chain is an interesting one. It's a challenging one as we move from the physical world to the digital world. Supply chain includes third-party dependencies on SaaS providers, third-party API providers, JavaScripts that run on your website that you didn't author, you're trusting someone else, that there's no vulnerabilities in those components. CI/CD pipelines, code signing, all the repositories that we access as we build based on open source software and code signing. Some of those issues are definitely bleeding into the zero trust space. I spoke to privileged access management, which includes many of those concepts listed, calling out orchestration and automation, a huge theme that I've seen recently, but also not a new concept. Orchestration and automation has been around since the aughts, the 2005, 2010. And it's interesting as many different vendors embrace and adopt the idea of infrastructure as code, being able to configure and deploy instead of humans through a browser and a GUI, programs making the changes that administer and operate our environments. We're doing that for consistency, very large environments where you need to deploy the same types of changes many times over. You want to eliminate fat finger mistakes. You also want to be able to audit those changes for some of the same reasons I mentioned before. Audit compliance, make sure the changes don't break the compliance that you worked so hard to achieve. And it's also for speed, for agility. This has been a slow roll because the processes required to deploy applications and technologies typically involves many different groups and many different components and products behind the scenes. And not all products and components work the same way. Because of just the human element of business processes, if the whole chain can't be orchestrated, then it falls back to traditional sequential, send an email to the next team, I'm done my work, you do your work now. But what we're seeing now is quite a trend of ubiquitous support for this type of approach. API-based configuration and monitoring, configuration through orchestration tools like Terraform and Ansible that dramatically accelerate how components, technology services can be rolled out, dramatically increasing the reliability and the later auditability, literally taking what once took months down to hours or minutes when it can be deployed through code. This is another area of trust. It's a new area that is providing a lot of advantages, but itself includes some trust that we need to address as security professionals in terms of how those processes are used in our organizations. And finally, the obligatory AI. It's required to be mentioned by every presentation, I think, these days. So at our company, AI is a huge part of what we do, using it for good, but AI is a new area of essentially implied trust right now. How are your employees using it to access external data? Is there data loss protection issues in terms of the types of content that are being fed into AI engines for analysis? Outside, our intellectual property is often exposed on the internet. How are third-party AI tools scraping our content, creating competitive differentiator for our competitors, etc.? What we think would be great in this world is some form of proxy type service that can inspect all forms of AI usage with respect to your enterprise, such that we can have a less trustful approach to it, right? So that we can monitor and audit and confirm what data is being shared with it, how it's being used, both by our own employees and externally, inward facing from the outside. Quick history. You can ignore the first one, but that's a pretty classic example of the problems of trust. Zero Trust has been around for a long time academically, emerged in 1994, the paper, University of Stirling, Stephen Paul Marsh, probably became, in the modern sense, famous with the paper, Forrester Research in 2010. But the point here is to reinforce this idea that this is not a hype cycle phenomenon. This isn't a technology. It's an approach that we have a lot of years ahead to further refine and think of all the areas where trust leaks into our environment. And it's hard culturally, I think, for many organizations to address. It sounds mean or rude in some way to not trust anybody. There's the famous, Reagan trust but verify comment back in the 80s. But this isn't about trusting people. This is about ensuring the right kind of access. It's far more about the verify side and taking the reverse posture to how open our environments are. Many steps along the way that matured our current environment of zero trust. But recently, in Canada, of course, this is some fun nighttime reading. If you're interested, the CCCS, the Canadian Centre for Cybersecurity, has posted their recommendations for large enterprise, for government deployment, on how zero trust architectures should be pursued. And this is to replace that classic, not replace, let me change my words, augment our previous approaches to the castle and moat architecture, because this is not a change that will happen overnight. It's not easy to do, but it is a different mindset. In the banking industry, Bank of Canada has posted their recommendations. From a government perspective, CISO in the US, the NCSC in the UK, have all recommended to government agencies and large enterprise to follow this type of approach. NIST has published, if you're familiar with NIST and the protected B, medium in Canada requirements, NIST 853, they have their own NIST 827 recommendation on how zero trust should be considered, again, accommodating the nuances that are going to be present in everyone's own environments. So I mentioned a little earlier that zero trust is not a product. But today there are lots of product-based approaches to it. And this is part of the snowballing product that I've seen throughout my 32 years now building networks of the technologies that we increasingly add to our environment. And the challenge, of course, are things like technical debt and managing the increasing complexity of additional tools everywhere. Many components fall into the category, thinking about, again, the previous categories of devices and users and applications and data, et cetera. And each of them have their own distinct approach. And it's very easy, especially from an engineering perspective, which is the world I come from. We have a propensity to add answers to problems and very rarely delete what we did before. There's a huge benefit and a focus for my company and others on simplicity. Simplicity is the ultimate sophistication. And it's not just for ease of deployment, ease of management. It literally lowers our risk. Simpler environments are less prone to errors, vulnerabilities. A different approach is required. So what are some of the additional challenges to zero trust? Why has it taken so long since 2010 for most organizations to embrace and adopt this kind of philosophy? Well, tying services into their existing environment, understanding the past and how new approaches change the past. Cultural resistance is one that should not be overlooked at all. It is a huge barrier to, this is not how we did things in the past. There's a new way of doing things, a new way of thinking about the problem that there is a lot of resistance to based on even specialization and understanding of different technology areas. There has to be an organizational top-down commitment to a new approach to how security is implemented. Bottom-up approaches stall for a variety of reasons. And it's because there's so many different teams that are stakeholders in the ultimate migration to zero trust. User experience is huge. It drove one of the biggest phenomena we've ever seen in the recent acceleration of zero trust approaches. That was the pandemic. Everyone suddenly working from home, needing a new way to securely access data with scalability and performance that simply wasn't available. In 2019, we were operating with a mentality of, 10% people were traveling, working from home. And then suddenly, one day, it was everyone. We needed a new way of thinking about this problem. And for many organizations, even for those small percentage of users that were remotely accessing their environments, they were still doing it with the mentality of, we'll just securely connect those users into our trusted environment, regardless of where the applications are located. And applications had spent the previous decade migrating from premises to cloud, and it suddenly became a very inefficient way of connecting users to applications. This is the user experience problem. Huge surge of remote users accessing data through an inefficient mechanism, routing traffic where it didn't need to go. We needed a new approach. And scalability, I think, there is obvious. Policy enforcement points became very key. It's driven for quite some time, even pre-pandemic, how Cloudflare is thinking about this problem. Policy enforcement points is something I've been thinking about since 2001, when Bruce Schneier, the semi-celebrity RSA presenter, spoke to me as a young and impressionable young engineer about how security services were built at the time. And he described, presciently, I think, 10 years before the creation of Cloudflare, a new approach to a security problem where the internet itself needed to behave differently. We need enforcement points everywhere, not just where we pre-plan choke points. A choke point for authentication, a choke point for firewalling, a choke point for VPN services. Those types of services needed to be ubiquitous everywhere. They needed to be deployable far easier than building physical appliances or even virtual appliances. A lot of this trend has moved to the cloud, but it's moved to the cloud in the same way that applications and data do, not the way networks do. Because appliances turned into virtual appliances that still required spinning up instances and routing traffic to a specific predetermined location between user and application or between application and backend data. Those inefficiencies came to a real head when we had our entire organization accessing data through inefficient paths. And we all know security is hard to adopt when users rebel. If the performance isn't great, it should be way better than it was before. And it wasn't. We hit performance limitations, scalability limitations, and suddenly security, well, that's not suddenly, that's not a new trend. Security took the blame for a user experience that suffered. Oh. There we go. Our approach, and others, we're not the only ones taking this approach or thinking this way, and we encourage many people to think this way, was to fix the problem that has been with us since 1969 or 1983, depending on how you think about it. An internet that was based on complete trust. Our approach was to think about a new way of constructing a global internet that has policy enforcement points everywhere, that customers don't need to think about where they are. Literally, a new version of the internet with a zero trust mindset baked into it. Deny by default, trust no one, authenticate everything, mutually authenticate applications, users, data, and continuously authenticate. Blend the world of protected or privileged access management into this concept of zero trust such that it doesn't just apply to critical infrastructure, but all access of your data. This is our version. Like I said, we're not going to be the only ones who approach this problem this way. This is a new way of thinking about addressing the complexity that exists with snowballing products built into an ever-increasing complex network environment. These aren't data centers the way you would traditionally think about our friends at AWS and Azure and GCP building data centers around the world, where you pick the location where your data and applications reside. We are thinking about this in the sense of a programmable, secure by design, new version of the internet that is very tightly integrated with the current internet. And the reason for this is essentially all of the bits that we can address, and I fully acknowledge we don't address all of the components that zero trust requires. You need to think about the devices and the posture of those endpoints, EDR tools that Cloudflare doesn't address, et cetera. But all these services need to work together in a programmable fashion, in a scalable fashion. These dots represent all of the interfaces of a single global firewall that doesn't require picking a location. It works wherever users or applications hit your data automatically. It is that version of the internet that didn't exist. So the way we approach this problem is building our policy enforcement points very close to your users wherever they may go. Employees traveling, office locations anywhere in the world, even customers accessing your data from out on the public internet. These represent virtual interfaces of a the physical interfaces of a virtual firewall that is pre-built. No new instances per customer, literally a new internet with over 330 terabits per second of bandwidth. It has to work at the scale of the internet. And we purposely build these locations very close to end users. So we are peered with ISPs, over 13,000 ISPs in the world, probably the biggest BGP peered network in the world. And the reason is for getting those enforcement points as close to any conceivable user without having to pre-plan locations and topology. So this collection of dots benefits every one of our customers, regardless how big or small. Their enforcement points follow their users automatically. This is a look quickly under the hood of how this is implemented, because the internet did not have all of these capabilities built in. Cloudflare, at its capacity with 330 cities and about the same number of terabits of bandwidth, runs on a single server. I don't mean it literally runs on a single server. We have tens of thousands of servers, but they're all essentially identical. The full stack of security capabilities that have been virtualized run on every server in every point of presence on that previous map, and then traffic is basically balanced across all of them. This means eliminating the concept of a scrubbing center. Security deployed in this fashion has to be thought of as an edge challenge, rather than, again, building a new perimeter somewhere else other than where your firewall used to reside. The concept of a scrubbing center, commonly used term in the DDoS world, but also applies to virtually hosted security services, suggests a choke point that is artificially selected. Maybe several of them, but if there's several of them, typically maybe 4, 5, 6 around the world. And so eliminating the scrubbing center and doing one-pass inspection as close as possible to end users, and having enterprises enabled with programmable policy enforcement very, very close, typically one hop from over 90 to 95% of the planet, and for the rest, probably 2 hops away, within their ISP. We are highly peered, as I mentioned, all of the ISPs in Canada. If you're hitting a Cloudflare-enabled site anywhere in Canada, it doesn't matter the service provider, the enforcement is happening literally at your service provider before that traffic goes across the internet, and never touched again. One-pass inspection with no rerouting of traffic to some other location. And I won't go into detail there, but there's sort of under the cover of what those remote points of presence look like, and a stack of services that exist within each server, effectively, passing packets in a single pass fashion through this stack of services. So it is very helpful, I find, to think of this approach as a single virtual firewall that happens to have 13,000 interfaces or more, where policy is enforced automatically for whatever traffic hits it that's destined for your environment. I guess that's it. That was anticlimactic. So this is a difficult topic, right? This is probably a theme that I think everyone is familiar with. We've seen it develop for the last at least 15 years. We've probably all struggled with the challenges of adoption. My message of simplicity is a key one from that modern perspective of engineering's propensity to add a new thing to solve a new problem. This kind of approach enables drastic simplicity. That problem that emerged in the pandemic of people working from anywhere should make it clear that if your most critical business applications and data are accessible from an employee sitting in a coffee shop, then that is the sum total of the complexity that your organization requires. Integrating this type of approach to a current environment requires that the approach not require changes to the current environment, so that changes happen at your own schedule. This is why our approach has been to build all of the services in a self-contained global network that don't demand any changes, literally, with any architecture you can imagine, to enable zero trust access for even a single user to a single application with no changes to that environment. So if you're a giant organization with 50,000 users going through a traditional castle and moat approach, you should be able to have 49,999 users use the existing method and one user easily using a new zero trust approach to access with all the attributes that I listed before. If it's not that easy, it almost won't happen. There are too many variables in this equation to align them all perfectly so that an application can be shifted over into the new mindset. So the philosophy that we've approached is, without any big transition required, enable this service even for a single user. This also applies to how we think about migrating applications to new locations. How long does it take to migrate an application from a private data center to a colo to a cloud provider? And where do those problems arise? Why does it take so long? One of the biggest ones, certainly from the perspective of everyone in this room, is rebuilding security policy around an application that has run for 20 years here under a new language and a new paradigm when it's moved here. And if I need to move it again, it almost always means rewrite the policy again using another language for the domain that you're moving it to. If policy can be separated from physical location and apply literally anywhere in the world, any cloud provider, any physical location, your private data center, on a server under the desk in the front office, colo space, your home office, exactly the same mindset, then moving workloads becomes trivial. You can do it every day of the week. You can turn on a new version of the application here and literally instantly turn it off again if the policy is exactly the same in the new location. This is our approach. Like I said, we're not going to be the only ones doing it. We've been doing this since about 2010, originally building this network on the backbone of global services like stopping the world's biggest DDoS attacks, unrelated to zero trust, but a critical function nonetheless in keeping our applications online, especially when those applications need to be flexible enough to run from anywhere these days. This is getting to a critical level, by the way. We've stopped 3 successive biggest DDoS attacks the world has ever seen since September, with the latest one being at 5.8 terabits per second. This is now being at the level where ISPs can be taken off the air with DDoS attacks. So it's a parallel thing that's related to this approach that this network type approach, global network approach, is starting to solve. Any questions for me? And I'd be happy to speak afterwards. Any thoughts? High-level discussion today, to be sure. Lots of challenges, I'm sure, in your own environments. Question?
Given the evolving landscape and potentially mitigating for yourself as, again, you're pretty much bigger now than the biggest ISPs in the world, how do you see yourself evolve to meet or mitigate the additional challenges that are coming now from your own lens?
It's a great question. I'm going to tie it to the context of this topic, too. One of the big questions we get is, you're saying you can't trust anyone, but you're actually suggesting a whole lot of trust in Cloudflare, and that's a very big and obvious one. One of the things that's happening with this theme of simplicity is shrinking supply chains, shrinking external dependencies. Verticalization is a huge theme in terms of folks trying to minimize their external dependencies. And we thoroughly understand our position and those who are taking the same sort of approach of being in a position of trust but verify. Our customers need to see how we operate. We need to be on top of compliance, of course. That obligatory buzzword again is AI is playing a staggering role in what we do today in terms of detecting, for instance, DDoS attacks or email-based attacks at scale, worldwide, millions and millions of customers, is requiring AI to fight AI. AI is impersonating humans. It is impersonating bots. So it's a big part of our strategy forward. And again, it's one of the things that I called out as a place of risk, not to trust. So this is going to be a battle kind of like bot management has been for the last 10 years. Constant evolution. And we view this type of approach as the fourth utility approach, gas, water, electricity, now secure internet services, as that sort of concept. We need to be transparent, and we are fighting every day to keep this kind of approach current. I think we're wrapped up. I will stay afterwards if anyone has any further questions or discussion. We'd love to connect with you all on LinkedIn, and thank you for your time.